I'm Dan Zhang, a technical account manager on the Android partner engineering team. And today I'm here to talk to you about how to maximize your app's reach by designing for devices with large displays. This is the first of a series of episodes, and today we'll focus on different input methods. As you know, the Android ecosystem continues to grow. More and more unique form factors are coming onto the market, providing a connected continuum. To name a few, there's already smart TVs, set-top boxes, and we're also starting to see in the pipeline these Android PC sticks, all-in-one smart monitors, and of course our own Google TV, which announced at I/O this year that they're migrating to stock Jelly Bean Android later this year. Now, these devices typically provide non-touch input methods such as joysticks, trackpads, D-pads, optical mice, etc. Now, the Android platform provides facilities for developers to target these new use cases, and that's what we want to highlight today. Now, these new form factors, like smart TVs, typically designed for living room and provide a 10-foot viewing experience. In other words, a non-touch UI. In the new Jelly Bean MR2 CDD, we have a new definition for the fake touch input, which is basically an alternative to the conventional direct touch interface, and provides support for point and click, drag and drop functionalities from a distance. Developers should improve their UX for fake touch devices. Again, the Android framework provides a set of APIs to help you define and collect these input events. We've listed a few of them here. We encourage you to read through these CDD definitions and framework APIs to understand how to take advantage of this input method. Now, in this simple table, we listed changes you should make to support the non-touch UI. In your Android manifest, all you need to do is make sure to remove the touch feature requirement unless it's absolutely necessary for your app. And you should consider fake touch as an alternative that provides more functionality than the traditional non-touch inputs such as D-pad can provide. Now, let's quickly look at a demo. To simplify things, we're using a Nexus 10 here with a USB mouse to emulate the fake touch input. This way we can work around the Play Store filtering for those apps that have not yet declared fake touch support. So here we have my favorite variation of the Angry Bird game, the Star Wars edition. Let's continue a game that has started. So as you can see, you can perform just about any functionalities you would with a full touch UI. You know, that wasn't a very good first try, but let me try again. So, you know, you could just fling the birds away using your fake touch inputs. But I should mention here, you're not able to perform multi-touch gestures in this setup because I'm using a simple mouse. But with devices that support multi-touch trackpads or pointers, you will be able to support these gestures such as zooming in and zooming out. So there you go. Please look into fake touch. So now let's look at making your apps more D-pad friendly. Now, D-pad has been around a long time. Even in some of the original smartphones, they were built in, and almost in all remotes, and obviously USB keyboards. So the reason we still want to look at D-pad is that even with this new CDD definition, some of the existing devices still may not support fake touch yet for some time. And even with the fake touch capable devices, it is often more effective and easier for users to operate remotes using just D-pad in a living room environment. Apps should support and respect all standard key events for basic navigation. So how should we actually optimize? Now, one thing we should focus on foremost is to address the focus handling. Basically, you want to make a conscious decision where to place the default focus to minimize key presses. The concept is simple. We shouldn't always assume users can randomly select an area on your page using touch. So we should utilize these APIs listed here to request default focus for certain elements or explicitly take over control for the focus sequence to traverse your pages. Another optimization tip is to actually change your layout to be more D-pad friendly. This is also not a new concept, and many apps designed for tablets have already adapted to this approach. But again, the idea here is to minimize number of key presses when the user tries to traverse through the page in a non-touch UI. In this case, you can jump forward in the tabs by traversing just left or right on the screen, which is much faster than scrolling all the way up or down through the page using a D-pad input. Again, to illustrate the relationships between these three input methods, we've added D-pad entry in this table. If your app is fully D-pad friendly, in other words, you can completely navigate throughout your app by using just the conventional D-pad and don't have to use any gesture control, etc., then you can simply declare just no touch or touch equals false in your Android manifest. And you may not need to consider fake touch. But going back to the previous example, Angry Birds, that app is actually a good candidate for using this new fake touch definition. So now let's do a quick demo. This time let's look at a Google service, the Play Movies app, also one of my favorite. I should mention that this app has made a lot of improvements in the last release to support D-pad, and as you see here in a second. So now I've switched to a USB keyboard, and you can see I'm able to traverse sequentially throughout the app by changing the focus on the top and selecting a content I wish to watch. Control playback, actually select the wrong key there. Here you go. So the movie started. So escape key would take me back one level, as you would expect, just like a touch input. So this is what I would call a D-pad friendly application. So that's all I have for you today. Please stay tuned for our next episode, and thanks for listening.